Welcome. We're going to be going over chi-square goodness of fit today. We're going to talk about the difference between parametric and non-parametric tests. We'll talk about how to determine the null and the alternative, and what observed values and expected values are. Hint, observed is what you just see. For instance, if you look around and count what types of phones people have, either Android or iPhone, the number, that's the observed, and the expected, we'll go through how to calculate, is based on the alternative hypothesis. So as mentioned, we have two types of tests now. We have what's called parametric and non-parametric tests. Parametric tests have more assumptions than their non-parametric alternatives. They're also more precise and accurate if the assumptions are met. So this means that observations must be independent, the observations must be drawn from a normally distributed population, which is not an assumption of non-parametric, and the populations must have the same variances, meaning that they both vary up and down. Think about it in terms of height for men and women. They have the same variances even though they have different average height. For non-parametric, there's less assumptions, which makes it easier to do. Their observations are independent, and the variable under the study has some underlying continuity, such as sex or passing or failing, or whether or not you're in college. There's some universal underlying continuity. So let's get into the chi-square goodness of fit. The chi-square goodness of fit is used with nominal categorical data. It is a non-parametric test. We are going to use observed and expected values, degrees of freedom, which equals k minus 1, which is k represents number of categories, only uses one variable, unlike another chi-square test which we're going to talk about and cover next in class, which is the chi-square test of independence. The assumptions: the data is nominal and categorical, such as either you have an iPhone or an Android, either you're attending Northeastern, you're attending DePaul or something like that, either you're in high school, college, or you're not in school. You only fall into one category. Each independent observation is well independent, and we use all the subjects around. Lastly, we need all expected frequencies to be greater. So if we're looking at expected values, we need more than 5 in each. So we need to expect more than 5 people to have iPhones, more than 5 people to have Android. For chi-square goodness of fit, we have two types of null hypotheses. We have the first, which is when no information is given in a statement. So we assume that all the frequencies are going to be equal. So all expected frequencies will be equal. The alternative is at least one category differs from the other. It's not going to be all, because we don't need all to be different. We just need at least one. The second one is based on information given in the statement, which is going to be frequencies in the target population are equal to the general population, such that the handedness of psychology majors are equal to that of the general population. The alternative is there'll be a difference between the target population and the general population. Observed and expected values. Observed is what you count. So for instance, how many lefties we count, how many righties, or how many males and females there are in a class. The expected must be calculated based on our null hypothesis. So for instance, if we just have two categories, we could expect a 50-50 split. So if we have 10 people, we would expect 5 in each category. Let's take a look at example 1. Is there a difference in frequency of number of men and women majoring in psychology at NEIU? So here we're not given any information as to what the breakdown might be. Therefore, it's going to be a 50-50 split. So our null is going to be frequency of men equals frequency of women, which means it'll be 50% for both. So say we have 20 people in the class, we'll expect 10 males and 10 females. The alternative is they won't be equal. So setting the null. When the null hypothesis is that all categories are equal, the expected value for each category is the proportion of people times the number of people that you observed. This also works for when you are given information, such as saying there's 90% of people are righties and 10% are lefties. You'll do the proportion times the number of people. So for instance, again, let's say we have 20 people. 90% are considered to be righty, or we expect them to be righty, so it'll be 18, because it's 0.9 times 20, which will give us 18. And then we do it again for righties, which would be 0.10 times 20, which will give us 2. Here's the chi-square formula. There is another PowerPoint that will be posted on how to actually calculate it, but it is pretty simple and straightforward. So the first step in calculating any chi-square, both the test of independence and the goodness of fit, is the observed value minus the expected over expected. The observed value is what we are told or we infer based on the information we're given, because we need to be given at least one group observed and the total, or all of them. The first step is to compute the difference between observed and expected. Then we square it, and then we divide that resulting value by the expected. And we do this for each and every level. We then add up each of those resulting values from step 3. So if we have 2, we should have 2 values. So if we have 2 categories, 2 values. 4 categories, 4 values. That'll give us our chi-squared obtained. So once we add up everything that's been divided by the corresponding expected, we are good to go. We then need to look at the degrees of freedom, which equals k minus 1, where k is categories, and we look up the value in the back of the book or in a chi-square table, where we will find our value, and usually we use an alpha of 0.05. Once you have your obtained and your critical, you draw out and determine whether or not you reject the null. Example 2, do psychology majors differ in handedness from the general population? And we will say the frequency of psychology majors handedness equals that of the general population, because we're comparing the two. And the alternative is going to be they're not equal. Assumptions for this test are that, again, nominal, categorical data. Each subject falls in only one category. Independent observations. We use all subjects. All expected frequencies are 5 or greater. We'll go through how to do this SPSS, but there's 2 methods. Regular, where you enter in 1, 1, 1, 1, 1, 2, 2, 2, 2, or you can do what's called the weight cases method, which we'll cover in class. Here is the APA style, and we just enter the information, degrees of freedom, and chi-squared obtained and p-value are all available through SPSS. And homework will be due 1 week from when we're done with this class. Here is how to specifically walk through step by step how to do your weighted cases.